Welcome back to the video for lesson 2.5 notes. This section is all about unions, intersections, and compound inequalities. So unions are when we're adding two separate groups together. So you could write this in words, adding two separate groups together. Intersections are where two groups overlap. So only the spot where they overlap is an intersection. And then compound inequalities. So when you've got X has to be between two values, or X has to be less than one value but bigger than another value. So let's look at the first situation. It's called the OR situation. Because the two inequalities are connected by the word OR, we graph their union. So OR means union. So we're graphing their union. That is, we graph all points on either graph because it's OR. X is less than a negative 2, or X can be greater than 3. So if either of the situations are true, the interval is true. Okay? So graph the solution and write in interval form. So let's graph the solution. So I'm going to mark a negative 2, and then we've got, let's say 0 is here, and then we've got 3 here on the number line. So X is strictly less than a negative 2, so it gets an open circle, and it's strictly less than a negative 2, or X is strictly greater than a positive 3. So in the interval form, I'm going to write the interval for the X is less than a negative 2. That's going to be the negative infinity with a parenthesis up to a negative 2 with a parenthesis because it's strictly less than. And then the union symbol is a big U for union. And then we pick back up again at 3 with an open parenthesis up to a positive infinity. Notice again, when it's negative infinity, you show it with the negative sign. A positive infinity does not need a plus sign, but you can have one. Again, this U represents for union. So anything less than, strictly less than a negative 2, or anything strictly greater than a positive 3. The other situation for a compound inequality is the AND situation. Because the two inequalities are connected by the word AND, we graph their intersection. So remember, when they're connected by an OR, we graph their union. When they're connected by an AND, we graph their intersection. The part they have in common, which is where they overlap. Okay? So here is X has to be greater than 4, strictly greater than 4, or it can be less than or equal to 8. So I'm going to draw 4, 5, 6, 7, 8. And it's strictly greater than 4, so it gets an open circle, but it's less than or equal to 8, so it gets a closed circle. And so we're saying everything in between there. And so that means in the interval notation, we have an open parenthesis at 4, comma, and 8 with a bracket. So that tells the reader everything between 4 and 8, where we're including 8 with the bracket. So we can use these ideas to take what we learned in section 2.4 with solving inequalities, and then we can solve compound inequalities. So I'm going to do example 3. Everything that's X'd out on my video here is because it's in the part 2 video. So A, B, and C will be on this video for example 3. It says graph the solution to each compound inequality and write your answer in using interval notation. So it's an OR. So X is either less than or equal to a negative 5. And we're just writing it in interval notation. We don't have to graph it on the number line. So less than or equal to a negative 5. So I'm going to do it right under here. So it's a negative infinity less than or equal to, so it gets a bracket. Or means I've got union, strictly greater than a -2. So it's a open parentheses at a -2 up to a positive infinity. Now B says x is greater than or equal to a -5, or x is strictly greater than a -2. Okay, so if we think about that, let's look on the number line. We've got a -5, so it's greater than or equal to a -5, which would be everything this way, or it's greater than a -2, which is everything this way. So really, it's everything all the way through the -5, because if either of those are satisfied. So we only have to write one interval because the second one is part of the first one. So it's a bracket at a -5 up to a positive infinity. Then it says, the third one says x is greater than or equal to a -5. So if I visualize this on the number line, we're starting here again. Greater than or equal to a -5. Or x is less than a -2. So I'm going to mark the -2 with an open circle, and it's is less than that. So now I'm going in the other direction. So it looks like everything's included, right? Everything from a -5 to the right positive, and everything at a -2 to the left negative. And the -2 is included because it's included in the first inequality. So that means I have everything from a -infinity to a positive infinity. And remember, I said that that can also be shown as this double R for all real values. D and E will be on the extra video. Okay, so let's take what we've learned and solve some inequalities in graphing. So we've got our inequality notation here in symbols, our interval notation here in symbols, and then graphing with our brackets and our circles. So you can either use brackets or circles when you graph on the number line. Let's look at example 4. I'm going to do example 4, A and B. So it says, solve the following inequalities. Use both a line graph and interval notation to write each solution set. Okay, so -3 is less than or equal to x plus 1 is less than or equal to 3. So we're really only worried about solving for x. So if I'm going to subtract 1 to solve for x, I'm going to subtract it in all three sides. So a -3 subtracting 1 is a -4. I subtracted 1, so I don't have to flip my inequality. 3 subtracting 1 is 2. So x is a solution set of everything that's less than or equal to 2, but greater than or equal to -4. So that means on the number line, I've got a -4, and I'm going to circle it in because of the less than or equal to, and a +2. I'm circling that in because it's a less than or equal to, and it's everything in between. And so the interval form is going to be a bracket at -4 and a bracket at 2. The great thing is with this lesson, you're getting practice with solving equations, you're getting practice with inequalities, and all of your answer notation all at once. So letter B says, we want to solve for x. We've got decimals. It looks like we have at most one decimal place on each, so I'm going to multiply through by just 10. So now it becomes 1 is less than or equal to 4x plus 1 is less than or equal to 3. That's much more simple. I'm solving for x. It might be helpful to use a colored marker to help to pull that out. So to solve for x, I'm going to first subtract 1. So I have 0 is less than or equal to 4x is less than or equal to 3 minus 1 is 2. I'm going to just rewrite it up here. And so again, I'm only worried about what's happening to x. So I'm going to divide by 4 to solve for x. That means I divide over here by 4 and I divide over here by 4. So 0 divided by 4 is just 0, is less than or equal to 4 divided by 4 is 1. So x is less than or equal to 2 divided by 4 is 2/4 or 1/2. And so again, I have a less than or equal to on both of those. So my 0 and 1/2, they both get a colored in circle because of the inclusion and everything in between. And then I've got brackets too, between 0 and 1/2 and a bracket there. And then example 5, A, B, and C are on the extra video. So remember, you only have to scan everything from the part 1 video. If you need extra help, you can watch the part 2 video. Catch me back for lesson 2.6.